For this practice sheet, I'm going to do a few, hopefully shorter videos, but run through all the pieces so you can see if there's anything weird that happens. I am going to be running these pretty quickly and not explaining nearly as much as what was in the videos from yesterday. All right, we're going to start by factoring. So x minus 2, x plus 2 over x minus 2, x minus 1. All right, cancel. Those are gone. My simplified function is just going to be x plus 2 over x minus 1. All right, to find a y-intercept, make x equal to 0. Let's see, so that's going to be 2 over negative 1, negative 2. So my y-intercept is 0, negative 2. X-intercept, I am going to make just the numerator equal to 0. So x equals negative 2. So, whoops, let's try and write that correctly. Negative 2, 0. Vertical asymptote, set the denominator equal to 0. So x is equal to 1. Horizontal asymptote, my leading terms are both either x squareds from the original or x's from the simplified, which means I can just divide the two leading terms or the leading coefficients. I'm going to have a horizontal asymptote of y is equal to 1. There is a hole in this graph, so I'm going to take the piece that I canceled, set it equal to 0. So that gives me half of my location. My other half, I'm going to take that x value of 2 and plug it in to the simplified version. So that's going to be 2, 4. All right, so I am now going to take my y-intercept, my x-intercept, my vertical asymptote, horizontal asymptote, and my discontinuity and graph them. All right. So 0, negative 2 on the y-axis, negative 2, 0 on the x-axis. Vertical asymptote, I'm going to go ahead and put this in, I guess in green. I'm going to narrow it down a little bit so it's not that big. All right, x is equal to 1. All right, so there's my vertical asymptote. Horizontal asymptote, y is equal to 1. Okay. And I have a discontinuity at positive 2, positive 4. So no extra point needed. All right, just draw in the curve. I should say curves plural because there are 2 of them. Make sure when you are approaching the discontinuity, the hole in the graph, that you don't actually draw through the open circle. You left it open for a reason. Okay, so problem number 1 is done. I'm going to slide on down to number 2 here. So problem number 2, I need to factor. This numerator, factor it whatever method you know, AC method, guess and check, pick whatever makes sense to you and make it work. The denominator is x plus 4, x minus 2. So let's see, 2x, x, let's go negative 2, positive 1. I want to do a quick check on that. 2x squared minus 4 plus 1, and then minus 2. All right, so that's a good factored form. I can then divide out those 2 common factors. So the simplified version of this is going to be 2x plus 1 over x plus 4. All right, let's get into this. Y-intercept, make x equal to 0. So 2 times 0 plus 1 over 0 plus 4 is 1/4. So 0, 1/4. X-intercept, set the numerator equal to 0. So x is going to equal negative 1/2. So negative 1/2, 0. Vertical asymptote, set the denominator equal to 0. So x is equal to negative 4. Horizontal asymptote, in this case, you've got the leading x's here. You have the same degree. So x to the first, just divide the coefficients. So 2 over 1 gives me a horizontal asymptote of y equals 2. We do have a hole in the graph, so I'm going to take the piece that I canceled out, set that equal to 0, so x is equal to 2. So 2 comma, and I got to figure out what that other piece is. So y is equal to 2 times 2 plus 1 over 2 plus 4. So that's going to be 4 plus 1 is 5 over 6. All right, so 5/6. All right, so all these bits, parts, and pieces are going to go on my graph. Okay. Be careful with the fractions that you don't have to go too insane with it, but just make sure they actually fit. So let's see, 0, quarter, and then I had negative 1/2 0. All right, that stay, it did not. All right, so let's see what we've got here. Vertical asymptote of x is equal to negative 4. So that's over here. Horizontal asymptote at 2. All right, so it's going to be 2 here. And we have a discontinuity, a hole in the graph at 2, 5 over 6. So 5 over 6 is almost 1. So basically somewhere around the 0.8 range. You can grab a calculator and figure it out. So I'm just going to go 2 and then almost all the way to 1 here. All right. So what this tells me is I'm going to need another point because, well, all of my values that I have so far are over here on the right, and I have nothing over here on the left. So I know my vertical asymptote's at negative 4, so I'm going to go ahead and just grab the next point to the left, negative 5. So if I use negative 5, let's see what happens here. So y is equal to 2 times negative 5 plus 1 over negative 5 plus 4. So negative 9 over, doing this in my head, negative 1, so just 9? 9. Okay. So this negative 5 right here, there's a point way up here at positive 9. So I'm going to go ahead and mark that. So now I know enough information to actually graph this thing. All right. So this is going to approach this vertical asymptote, curve down, and approach the horizontal. And on the right side here, we're going to come up from this. That's kind of horrible looking. Let me try that again. Slightly better. Remember, don't draw through the discontinuity that you drew for me. Okay, make sure to leave it an open circle. So that's problem number 1 and problem number 2. I'm going to go ahead and cut this video. I'll make separate videos for 3, 4, and then probably 5, 6, 7. We'll do separately as well.